Hi friends, very good evening. How are you all? How is progress in physics? I hope you are doing fine. Who is online today? Yeah, I'll check. Hi Pratap, very good evening. Mansi, good evening. So still, many have to join. For the competition, heavy neck-to-neck battle is going on for the last 3 to 4 weeks. So still waiting. Deepak, Radhika, Manasvi, yeah, very good evening Manasvi. Yeah. Shall we go ahead with the session? Okay. And in the last session, I had given a problem. In a single slit diffraction, having a wavelength of lambda by a slit of width small e, size of the central maximum on a screen at a distance b. Hi Radhika, very good evening. So, this problem most students got wrong. Maybe a conceptual lagging or a calculation lagging. Anyway, till now I have not started diffraction, but briefing I am giving regarding this. Hi Indrajit, very good evening boss, how are you? I am plotting a figure. First minimum on either side of the central branch, given that slit width is small e, you are asked to find the width of the central max. Width of the central max in the figure is given like this. It is nothing but this e plus this x plus this x. So, W equation is 2x plus e. But how to compute x? Simple. This angle, for example, theta. This angle will also be equal to theta. Sin theta. When theta is very small, as per trigonometry, we can express sin theta as tan theta is equal to theta. Sin theta is equal to theta, that is equal to tan theta, that will be equal to x by, in the problem this screen is located at a distance of small b, x by b. Therefore, x is equal to b into theta. You got the clarity? It's a very good problem. Whatever the problems I am giving you for solving, very worthy problems. Try to have grip over them. Now, it is the time to express theta. When you know that the condition for first min, path difference delta x is equal to n lambda, but we know that delta x by small d, here small e, is equal to sin theta. Therefore, delta x n lambda by e is equal to theta, but it is mentioned in the problem first min. Therefore, after the sixth step, come back here. N is equal to 1. Therefore, theta is equal to lambda by e. Now problem is over. W is equal to 2b into lambda by E plus E. Now I think everyone has understood the problem. Hi Jitesh D'Souza, how are you? After a long time I am finding you, D'Souza. Where were you during all these days? I missed you in the last and last before class also. So I hope now everyone has understood the concept behind this problem. It is a very good application on diffraction. Now let us go to the goals of the today's session. Brewster's law, which we have to finish in polarization. After the Brewster's law, I will gear up with the diffraction, and in the diffraction the key areas are condition for secondary max, condition for secondary mean, followed by width of the central max and numericals. Now let us go to the Brewster's law. We know that in polarization there are different ways of achieving it. Polarization by reflection. When you observe this is unpolarized light. This is unpolarized light which is incident on a surface at some angle of incidence small I, and a part of the light is reflected in this direction. A part of the light is refracted into the other medium. So when you observe this diagram, this is incident beam or incident light, this is reflected light, and this is refracted light. Now slowly I am increasing, I am changing the angle of incidence. For a suitable angle of incidence, the reflected light is completely polarized. So the reflected beam is having only the dot components. Having either dot components or arrow components states that that light is polarized completely, and this complete polarization of a reflected beam happens only at a particular angle of incidence. The particular angle of incidence at which a reflected light is completely polarized is called as the angle of polarization. So I is equal to P. At all the angles of incidence, you won't get reflected beam completely polarized. For a particular angle of incidence, what is the name of that particular angle of incidence? Known as angle of polarization P. Reflected light is completely polarized. This is angle of reflection, small r. This is angle of refraction, r dash. Then what about the refracted beam, sir? You may ask a question. See, the refracted beam will be like this. It is having unequal number of arrow components and dot components. When they are unequal in number, it is not completely polarized. It is said to be partially polarized. Complete polarization and partial polarization difference is that for complete polarization only one type of components should be there. For partial polarization both components will be there. They are unequal in number. If they are equal in number, then it is said to be unpolarized light. So refracted light is partially polarized. At an angle of incidence equal to angle of polarization, the angle between the incident light and refracted light will be equal to 90 degrees. So in the figure I mentioned that angle between the reflected beam and a refracted beam will be equal to 90 degrees. Next, when this is equal to 90 degrees, immediately we can get the r plus r dash will be equal to 90 degrees. Then I want to know the refractive index of the medium. As we knew, mu is equal to sine of angle of incidence by sine of angle of refraction, r dash. But r dash is nothing but 90 minus r. R dash is equal to 90 minus r. Therefore, mu is equal to sine I by sine 90 minus r, that is nothing but cos r. But as per the laws of reflection, angle of incidence and angle of reflection are barabar. But I is equal to r, that is equal to angle of polarization p. Therefore, mu is equal to sin p by cos p, that is equal to tan p. This law is called as Brewster's law. The refractive index of a medium is equal to tan of polarizing angle. In polarization, the concepts which I am feeding you in the last class, we discussed about the law of Malus. Now, this is Brewster's law. Both will carry good amount of problems in both NEET as well as JEE. So, finally, the essence of Brewster's law, when angle of incidence and angle of polarization are same, means the particular angle of incidence at which reflected light is completely polarized is called as polarizing angle. When this happens, the angle between I and reflected beam and a refracted beam will be equal to 90 degrees. Then I have given a set of mathematical steps. The angle of incidence will be equal to polarizing angle P. Then from the geometry of the diagram, r plus r dash is equal to 90 degrees. Mu is equal to sin I by sin r dash. Therefore, r dash is what, sir? Angle of refraction. R dash is equal to 90 minus r. Mu is equal to sin I by sin r dash. By putting that, you will get sin I by cos r. But all this phenomena will happen at I is equal to P. Replace that. Then finally you got with the refractive index of the medium is equal to mu, that is equal to tan of polarizing angle. Now let us get up for the problems. So the game starts. Who are in the line once again? Only these people. Mansi, Manasvi, Radhika, Indrajit, Jitesh, D'Souza, Pratap Singh. Still any others? Apeksha, Josna, where are you all? So let us get up for the problems based upon the concept known as Brewster's law. In the last session we have finished all. Now it is the time of Brewster's law. When you come to the Brewster's law, the only equation that will matter is nothing but mu is equal to tan of polarizing angle. Problem number 1. Angle of polarization. Angle of polarization for a medium is equal to 60 degrees. Then find critical angle. Your time starts. I am giving the problem narration. Angle of polarization for a medium is given as 60 degrees. My requirement, find the critical angle for the given medium. Attack. Your time starts. I will just see who will be the fastest solution provider. D'Souza, Indrajit, Radhika, Manasvi, Mansi, Pratap Singh. Get up. Eagerly waiting for the reply. Eagerly waiting for your message. Time is running out. Radhika. Arey yaar. It is incomplete answer I am finding, Radhika. Mansi, Radhika, root 3. This is you. Josna. Oh, Josna entered the game. Fantastic. 3 root 2. Still answers. 35.26. Very good. Very good. Gear up, Radhika. So, the answer for the given problem, I think Radhika is nearer to the final answer, and all others are also. Maybe it is problem to express mathematical functions through message. I understood your problem. Everyone has finished in a fantastic way. Just I am giving the narration of the problem. In this problem, theta, they mentioned polarizing angle. So mu is equal to tan P, tan 60 is equal to root 3. But our requirement is find the critical angle. Maybe you know mu is equal to 1 by sin C. Relation between refractive index and critical angle, that is equal to root 3. Therefore, sin C is equal to 1 by root 3. I want my requirement critical angle C, that is equal to sin inverse 1 by root 3. This is the answer. I think everyone has got this. Please respond, Apeksha. Whoever got the same answer that I have presented on the screen, say yes through message. Because this is the actual problem. I thought it is not possible for you to send the sine function through the message. Am I right? Radhika, Josna, Apeksha, today you entered the game very early. Very good. Fantastic. Apeksha, very good boss. Really great. So I know everyone can solve this problem very comfortably because you are groomed in such a way that you are finding a lot of enthusiasm in cracking the problems. That enthusiasm is a fuel for physics. Very good. Shall I proceed for the second problem? Will you permit me for the next problem? Good. Yeah. The angle of incidence at which reflected light is totally polarized for reflection from air to glass refractive index is equal to n. This is Indrajit, carry on. The angle of incidence at which a reflected light is totally polarized for reflection from air to glass. Your time starts. Gear up. Yeah, your time starts. Countdown started. I am waiting for the answers. Apeksha, where are you? Josna. Yeah, tan inverse n. Fantastic. Radhika, it is tan inverse n. Very good. Again, today also Radhika is showing her complete supremacy. Fantastic, Radhika. Congratulations. Apeksha, Josna, I know that you are equally competent, but I need more fastest reply because our NEET, our JEE is a racing game. Everybody, whoever does the problem very fastly will be the first winner. Fantastic. See, so it is nothing but a tan inverse n. Now, I am proceeding to the next problem. A beam of light is incident on a surface at theta is equal to 60 degrees, and it is observed that reflected light is completely polarized. Then find velocity of a refracted ray inside is equal to how much? Your time starts. Apeksha, a beam of light is an incident on a surface at theta is equal to 60 degrees, and it is observed that a reflected light is completely polarized. Find velocity of a refracted ray inside that medium. You can express the answer either in the form of C or in the form of a number. Yes, Radhika, Apeksha, Mansi, Pratap Singh, Josna, where are you all here? I want complete communication with me for everything. Be in touch. Yeah, your time starts. Countdown has already started. Your answer, eagerly waiting for your answer. Already Radhika took the advantage of the second problem. Now, Radhika entered 1.73 multiplied by 10. 10 to the power of 1.73 into 10 to the power of 8. Fantastic, Radhika, fantastic. 1.73 multiplied by 10 power 8 is the correct answer. Fantastic. Answer is root 3 into 10 power 8 or C by root 3. Still, I am expecting many more to finish the problem. Jaldi. Eagerly, yes. Apeksha, you are also right. Why Radhika? You are also right, Apeksha. Carry on. Mansi, fantastic boss. Fantastic answer. Still. Pratap Singh, Mansi, Manasvi, Josna, I am waiting for your answers. Yeah, Mansi, perfect boss. Let us see the problem. Mu is equal to tan 60. After finding mu in your ray optics, you have a formula. Refractive index is defined as speed of the light divided by speed of the light in the medium. So they have asked V. V is equal to C by mu. Very good. Now it is a time to discuss about the diffraction. Are you ready? Shall we get up for the diffraction? Yeah. Actually, it is a figure related to the diffraction. Now, my question to you, already you had exposure to the polarization as well as interference. Now you are well equipped with both these areas. Now let us see diffraction phenomena. Diffraction in layman language, we can say bending of the waves. In layman language, we can say bending of the waves. When you take a diffraction of the light is possible when the wavelength of the incident light matches exactly with the size of the slit on which it is falling. When the wavelength and the size of the slit are matching, immediately you will notice there is a bending of wave. That bending of wave is termed as diffraction in light. Got the clarity? So, diffraction of the light is possible. This is a theory bit previously given in JEE mains. Diffraction of the light waves is possible only under one condition. That condition is that the wavelength of the light should exactly match with the slit gap or slit width or aperture. Hi Naveen, very good, how are you? Now we have the concept called as Fraunhofer diffraction, single slit Fraunhofer diffraction, SSFD. This is geometry of the single slit Fraunhofer diffraction. Here we have taken a plane wavefront, and this plane wavefront is incident on a slit having a width of B units. Here whatever the variables I am showing in the figure, they are exactly similar to the variables already I used in interference concept. Here B is called as slit width or the gap or the aperture or the obstacle. So the plane wavefront is falling, and in the interference phenomena I show the distance between the screen and the slit as capital D, so that if I use the same alphabets you will not having a confusion. So capital D again I am using as the gap between the screen. Hi Naveen, fine, fantastic boss. Now this plane wavefront is undergoing this ray diagram. I mean these two things, you observe the path of my pen are meeting exactly at the point C by traveling equal lengths. When they travel equal lengths, then the length gap will be equal to 0. Length gap is equal to 0 implies path difference is equal to 0. Then at the point O on the screen, you will find a maximum band, that is nothing but central bright. For forming central always bright, the only reason is that there should not be any path difference between the waves. Path difference in layman language, one boy is running fast, other boy is relatively slow. Whatever the road gap, whatever the length gap between the two boys, it is defined as path difference. So this one, 1, 2, 3 all met point O with equal path lengths, making path difference will be equal to 0. So you will observe a bright on the point O, that is called as a central bright. And in our interference I made point P as the point of observation. So here the point P is again here also point of observation, and the distance of the point P from the center O is given in our interference as y. Here also y is the distance of point of observation from the central bright, and whatever here this double headed arrow, it is showing path difference between the waves traveling from A to B and meeting at the point P. So in this I am giving few mathematical equations which will make you comfortable. This angle is equal to theta. Then in interference also I have given sin theta is equal to delta x by slit width. Here the slit width is again I am giving it as a small d only to avoid the confusion, delta x by d. Then delta x is equal to d sin theta. Delta x is equal to d sin theta, where delta x is equal to path difference between the waves meeting at the point P. Delta x is given as d sin theta. One simple thing to handle diffraction problems very easily, the interference laws are reversed in diffraction. There in the case of the interference, you had path difference condition for . path difference condition for the maximum intensity called as construct interference delta x is equal to n lambda. I hope you remember the last lesson. And for the destruct interference, it was given as 2n plus 1 into lambda by 2 or 2n minus 1 into lambda by 2 based upon the initial value of n you are taking. So here whatever the conditions there we had, those conditions are reversed, means constructive interference condition in the case of the diffraction will be reversed. There it was a bright condition, here it is a dark condition. Similarly, destruct interference condition is reversed here, it is for brightness. So if you keep those things, these things will be very easy. Hi Manan. Now here I have given another figure where the variation in the brightness of the light on the screen. As you noticed, the brightness is maximum at the center and we call it as central max. So in the diagram I am coloring with red. So this is all central max. And after that, immediately after central max, you are finding first min on either side of the central max. Now apart from central max, listen very carefully here. Apart from central max, all other maxima or minima are called as secondary. They are known as secondary, except central max. Whatever the bands that are obtained on either side of the central max are considered as secondary. If it is a first bright band, first secondary max. If it is a dark band, we call it as a first secondary min. So here on either side, at this point you found first secondary min. Simply you can say it as first minima. But in the problem they will ask you first secondary min. And from here to here, from this dot to this dot, it is called as width W of the central max. W of the central max. And theta is the angle made with respect to this. And we know that the slit width is equal to small d. And the width W is defined as this 2x. Linear width is equal to 2x. And angular width is equal to 2 theta. Linear width is equal to 2x. Angular width is equal to 2 theta. So if you know the value of x, if you double it, you will get the linear width. In a diffraction, when you observe the problems in JEE or this NEET, you will find that those problems will be fired only on 3 areas. Area number 1, finding the distance of nth secondary min or nth secondary max. This is the area 1 where we can expect the problem. Finding the distance of secondary min or max. Another area, you will be asked to find a diffracting angle, that is nothing but theta. And third one, you will be asked to compute width of the central bright. More than these 3 areas, they will never cross any problem. If you are thorough with these 3 areas, number 1 area, finding the distance of nth secondary min or secondary max. And second one, finding the diffracting angle theta. And third one is width W. And secondary maxima condition. Already I told that the minimum condition in in the interference is a secondary maxima here. Minimum condition in interference is a secondary maxima here. So path difference delta x is equal to 2n plus 1 into lambda by 2. Path difference delta x for secondary maxima, maxima condition in a diffraction is equal to the minima condition in interference. As you already got, delta x is a path difference. It is equal to 2n plus 1 into lambda by 2. Next, distance of the nth secondary. Say for example, this distance I need from the central bright. this distance is y. So distance of the nth secondary maxima is equal to yn is equal to 2n plus 1 into lambda by 2 into capital D by small d. Yn is equal to 2n plus 1 into lambda by 2 into capital D by small d. And we know that delta x by small d is equal to sin theta. So delta x is equal to d sin theta. If theta is very small, then we can write sin theta as theta, and therefore theta is equal to delta x by d. These are the valid equations related to the secondary maxima. I will, any doubt, brief recap. Delta x is equal to 2n plus 1 into lambda by 2. Yn, distance of the nth secondary maxima. Then sin theta, delta x by d. Then delta x is equal to d sin theta. If theta is very small, theta can be written as delta x by small d. Secondary minima, as I said, it is a condition of maxima in interference. So if you remember like this, it will be very easy. Then delta x means condition for the path difference n lambda, that is the thing. So delta x is equal to n lambda. Distance of the nth secondary minima yn is equal to n lambda into capital D by small d. Next, when you observe that theta is equal to delta x by d, in the place of delta x you can replace n lambda by d. These are the valid equations. In this case you have to replace 2n plus 1 into lambda by 2 into d. So if you are thorough with these equations, it will be very easy. And in some problems they mentioned they use a lens, they use a convex lens to exactly focus the beam. In such a case they will bring the focal length f into action. F is equal to focal length of the lens. In such a case, for mathematical operations we can take f nearly approximately equal to capital D. So wherever capital D is there, then you can restructure the formula with focal length into action, n lambda into f by d. So these are the valid equations. If you are thorough, I will get up for the problem. So shall we get up for the problems? If you say yes, I will get up for the problems. I am waiting for your messages. Yeah. Now problems based upon the diffraction. It is the time of problems based upon diffraction. Problem number 1. I will see how you will be able to handle this concept. A slit of width capital A is illuminated by white light for lambda equal to 6500 angstroms. The first mean, whichever the keywords in the problem I am underlining, the first mean is obtained at theta is equal to 30 degrees. Then the value of A is equal to, once again I am dictating the problem. A slit of width small a is illuminated by white light for lambda is equal to 6500 angstroms. The first minimum is obtained at theta is equal to 30 degrees. Then you are asked to find the value of the slit width A is equal to how much? This is the problem. Option A, 3250 angstroms. Option B, 6.5 into 10 to the power of minus 4 millimeter. Option C, 1.24 microns. And option D, 2.6 into 10 to the power of minus 4 centimeter. Yes, your time starts. Contrast started. Countdown has started. Now gear up. The first problem in the diffraction concept. I am eagerly waiting. Who will give the first reply? This time I am expecting from Apeksha, Naveen, Manan, Mansi. Overtake Radhika. Try to overtake Radhika as early as possible. Radhika, you have to keep up your position. Don't give a chance to them. So it's a very tough game between all of you. So I am eagerly waiting for the quick reply. I am waiting for your message. Your time is running out. A slit of width small a is illuminated by white light for lambda is equal to 6500 angstroms. The first minimum is obtained at theta is equal to 30 degrees. Then the value of a is here. This is the problem where you will be asked to find the slit width. Waiting for the answer. Yes. Now, see I am giving. They mentioned that first mean is obtained. Distance of the first mean as per our just now I briefed you. Yn is equal to n lambda capital D by small d. Now it is mentioned that first minimum. So take n is equal to 1. Then very good Radhika. 1.24 microns is the perfect answer. 1.24 microns means micro 1.24 into 10 to the power of minus 4 centimeters. 1.24 into 10 to the power of minus 4 centimeters. That is nothing but 1.24 microns is the perfect answer. So here you can see the solution. Yn is equal to n lambda d by small d. They mentioned first mean. So you have to keep n is equal to 1. So this is equal to lambda d by small d. But they have given distance yn in terms of the angle. So you have to convert in the form of radian. So our requirement here is to find slit width. Here d is given as a. So a is equal to lambda d by yn. Now we know that 360 degrees or pi radians is equal to 180 degrees. So they have given 30 degrees. So 30 degrees is equal to how many radian? Pi by 6 radian. So in the place of yn, you have to replace pi by 6. Therefore complete solution will be 6500 into 10 to the power of minus 10 into 6 divided by pi. Your answer will be 1.24 into 10 to the power of minus 4 centimeter. That is nothing but 1.24 microns. Very good. Apeksha, I want you to be coming to the front line along with others. So I have provided the solution. Slowly if you practice, you will get the edge over others. So Apeksha, be active and I am providing the solution. Any doubt, please share with me. I am proceeding to the problem number 2. In the problem number 2, we are dealing with the finding the central width of the central bright. So this is a problem related to width of the central bright, that is a slit of size 0.15 centimeter is placed at 2.1 meter. Josna, where are you? You are not, I am not finding you on the screen. Josna, Pratap Singh, Mansi, where are you all? 2.1 meter from a screen illuminated by light of wavelength lambda is equal to 5 into 10 to the power of minus 5 centimeter. Then find width W of the central max. I am giving the narration. A slit of size 0.15 centimeter. For solving any problem, you are having just 3 steps. Whatever the value they mention in the problem, try to convert them in the equivalent symbols. Here they mentioned 0.15 centimeter. In our notation, 0.15 centimeter equivalent symbol is D. D is given as 0.15 centimeter is placed at 2.1 meter. Equivalent variable for 2.1 is capital D, 2.1 meter, and lambda is provided. Lambda is equal to 5 into 10 to the power of minus 5 centimeter. For any problem, just you are having a technology called as DDR. First D for data. Second D, demand. Demand means what they have asked in the problem. R for relation. Relation matlab formula. So if you implement this DDR technology, it will be very easy to find the answer. So answer is equal to, already Radhika is on the screen, 1.4 millimeter. Fantastic. Answer is equal to 1.4 millimeter. So for this, already I have given width W is equal to 2x. In our diagram, what I have shown, you are asked to find the width of the central bright. This they have asked. So I am providing the screen once again. This width W they have asked. Width W, that is nothing but central bright width is equal to, in this figure, you can see this width W is equal to either 2x or 2 theta. So come back and apply that in this. So when you observe this, that is equal to 2x, that is equal to 2 into lambda capital D by small d. So width W is equal to 2 lambda into capital D by small d. Capital D is given, small d is given, lambda is given. You will come out with the answer as 1.4 mm. So that is the problem number 2. The solution is provided. And in your assignment, I have provided the best problems. I have given 10 problems and 1 for discussion. So you be thorough with those problems and just go through them very nicely, because I have collected those problems exclusively for you. So try to focus those problems and try to crack those problems, because all the concepts I have given, and I made you to practice a good number of problems in the running session. So now it is a time for you to go through those problems and try to analyze problem to problem. I have covered all interference, diffraction, polarization in the assignment which I have given today. So you just go through them, try to apply the concepts and take them advantage of those problems. Thanks for joining us. Fantastic. Have a nice day, my dear friends. Bye-bye.